Welcome to qnawire.
So in order to find the net charge enclosed by a closed surface, it's going to be given by Q equals, we'll see if they have epsilon. If not, yeah, we'll just do E naught times the double integral of E dot ds. And then we're able to divide the surface S into two different parts, which will be a hemispherical part and a bottom disk. So the surface has the form z is equal to g of xy, which is oriented upward. So if we want to find the flux through the hemispherical part, we'll use the 10th formula, which states that the integral, or the double integral of E dot ds is equal to the double integral of negative P times the partial derivative of D with respect to x minus Q times the partial derivative of G with respect to y plus R dA. That's capital R. And another thing we note is that E is equal to this right here, P, Q, and R. And since we know that E is x, y to z, we can replace this with x, y to z. So when it comes to our z value being positive, we know that z must be equal to the square root of a squared minus x squared minus y squared, because it's the upper half of the sphere. And then now replacing these values, we want to take the partial derivative of this with respect to x and y in order to incorporate it into this formula right here. So we know that P is x, Q is y, and R is 2z. Then we also know that the partial derivative right here is going to be a negative x over the square root. It's just going to be over z. So we'll do this right here. And then this will be a negative y over this right here. So with all this, we can combine them. We'll get a positive x squared, a positive y squared. And as a result, we will be able to simplify all of this into x squared plus y squared over that right there. And then since we know z equals x squared plus y squared, it's just going to look like that, which then we note D will be a projection of the surface on the xy plane, and it's a disk with radius a with its center at the origin. So using polar coordinates, we have this as the radius, and then 0 to 2 pi as the angle measure, theta. So we will change the coordinates to polar. So x squared plus y squared becomes r squared. This right here becomes a squared minus r squared. And then this becomes a squared minus r squared as well. And then we'll have r d theta. And getting rid of this. Then we'll move these terms around, so we can move this inside of here. And this will just be d theta. And as a result of that, this will just become 2 pi. Then putting parentheses around this, we will have a more clear answer, but we do not know what A is, so we can't determine that. Using substitution method, we will simplify this further and determine that this will be 4 pi, or just 4a cubed over 3. So when we multiply this, 4a cubed over 3, our final answer for this is going to be an 8 pi a cubed over 3. Then we want to find the flux through the disk. Since the disk is part of the surface, z equals 0, what we see is that when we take the partial derivatives, before we'll just get 0. So we'll have x times 0 minus y times 0 plus 2z, but we know that z equals 0, so it's all going to be 0 essentially. So when we add this, it'll just be what we had before, which tells us that the charge enclosed, we have to remember from before, we just multiply the E naught after the fact, or the epsilon naught after the fact. So this will be our final answer, because we can't forget to multiply this once we've done this portion.